The different types of coupling. Rigid coupling, sleeve or muff coupling. Clamp or split muff or compression coupling. Flexible coupling. Bushed pin type coupling. Bellow coupling. Ear coupling. Universal coupling. Diaphragm couplings. Fluid coupling. Constant speed coupling. Oldham coupling. Jaw couplings. Fludex fluid coupling. Coupling, rigid sleeve coupling. And flange coupling. Variable speed coupling. Number 1. Rigid coupling. A rigid coupling is used when two shafts are perfectly aligned. These are only suitable in close alignment. X. Sleeve or muff coupling, split muff coupling, and flange coupling. Number 2. Sleeve or muff coupling. Muff or sleeve coupling is the simplest type of rigid coupling. This is made up of cast iron. Construction. Muff coupling consists of a shaft, key, sleeve, or muff, and a hollow cylinder whose inner dia is the same as that of the shaft. It is fixed over the ends of the two shafts with the help of a gib head key. The power transmission is done from one shaft to the other shaft by means of a key and a sleeve. It is necessary that all the elements must be strong enough to transmit the torque. Number 3. Clamp or split muff or compression coupling. It is also known as split muff coupling. In these types of couplings, the muff or sleeve is made into two halves and is bolted together. The halves are made of cast iron. They are connected together by means of studs or bolts. Both shafts' ends are connected to each other and a key is fitted in the keyway of the shafts. One end of the muff is fixed from below and the other end is attached from above. Both are held together by bolts and nuts. This coupling is widely used in heavy-duty speeds. There is no need to change the position of the shaft to assemble or disassemble the coupling. Number 4. Flange coupling. It consists of two cast iron flanges which are fixed at the end of each shaft. The two flanges are bolted together with bolts to complete the drive. A flange coupling is to bring two tubes together in a sealed manner. One of the flanges has a projected portion part and the other flange has a similar recess. Each flange end is bought together to make correct alignment without causing resistance in the material being passed through them. It helps to bring the shaft into the same line and to maintain alignment. The two flanges are coupled together by means of nuts and bolts. These couplings are typically used in pressurized piping systems. Also, it is employed for heavy loads, hence, it is very beneficial on large shafting. Following are the three different types of flange coupling. Unprotected type flange coupling. Protected type flange coupling. Marine type flange coupling. Number 5. Flexible coupling. It is used to connect two shafts that have both lateral and angular misalignment. Example: bushed pin type coupling, universal coupling, Oldham coupling, gear coupling, bellow coupling, jaw couplings, diaphragm couplings. Number 6. Bushed pin type coupling. This is used for slightly parallel misalignment, angular misalignment, or axial misalignment of the two shafts. It is a modification of the rigid flange coupling. It consists of two halves that are dissimilar in construction and bolts known as pins, rubber bushes which are used over pins. There is a clearance of 5 mm between the faces of the two halves of the coupling. There is no rigid connection between them in the drive done through compressed rubber or leather bushes. Number 7. Universal coupling. The universal coupling is also known as Hooke's coupling. It is used when two shafts' axis intersects at a small angle. The inclination of two shafts can be constant, but in actual practice, This changes when the motion is transferred from one shaft to another. A universal joint is shown in the above figure. These couplings are widely used in the transmission of power. Universal coupling is found in the transmission from the gearbox to the differential of the automobile. In these cases, two universal joints are used on each end. One at the end of the propeller shaft to the gearbox and one on the differential to another end. Universal coupling is also used for the transmission of power to different spindles of multiple drilling machines and milling machines. 8. Oldham coupling used where two shafts have a lateral misalignment. The below figure shows the schematic diagram of Oldham coupling. As a figure, it consists of two flanges A and B with slots and a middle floating part E with two tongues T1 and T2. The middle part is fixed by means of pins that are fitted to flanges and floating parts. The T1 tongue fits into flange A allowing back and forth motion, and T2 is fitted into flange B and allows for vertical motion of the parts. These two components of speed will result in the lateral misalignment of the shaft being adjusted as they rotate. Number 9. Gear coupling. The gear coupling is a modified version of the flange coupling. Gear couplings can transmit high torque because of the large size of the teeth. In this types of shaft coupling, the flange and hub are separately assembled together instead of as a single part as flange coupling. In construction, each joint has a 1:1 gear ratio, internal and external gear pair, and gear coupling is limited to angular misalignments about 0.01 to 0.02 inches in parallel and 2 degrees in angular. Gear couplings and universal joints are used for similar applications. These are mostly used in heavy-duty applications where the torque transmission is required to be high. Number 10. Bellow coupling. Bellows couplings are flexible coupling with twin coupling ends called hubs. These couplings have excellent torsional rigidity to accurately transmit velocity, angular position, and torque. They are usually made up of stainless steel. These couplings are used where high precision positioning is required. Bellows coupling consists of thin walls and has minor flexibility. Angular, axial, or parallel misalignment. The hubs are welded to the coupling bellow. These couplings have the highest torsional stiffness of any servo motor coupling. 11. Jaw coupling. This coupling is used for general-purpose power transmission. It is also used in motion control applications. Jaw coupling is designed to transmit torque while reducing system vibrations and adjusting misalignment, which protects other components from damage. Jaw coupling consists of two metallic hubs and an elastoplast insert called an element, also known as spider. Following are the advantages of jaw coupling. This system can handle angular misalignment and reactionary loads due to misalignment. Has a good torque to outside diameter capability. Good chemical resistance and decent dampening capability. Number 12. Diaphragm couplings. Diaphragm couplings are one of the non-lubricated couplings used in high-performance turbomachinery, transmitting torque and serving misalignment between equipment shafts. This type of coupling transmits torque from the outside to inside diameter, and then from inside diameter to outside diameter. Diaphragm couplings uses a single or a series of plates for the flexible members. Diaphragm coupling allows angular, axial, or parallel misalignment. This coupling is used where high torque and high speed required. Number 13. Fluid coupling. A fluid coupling is also known as hydraulic coupling. It is a hydrodynamic device used to transmit rotating mechanical power through the acceleration and deceleration of hydraulic fluid. It consists of an impeller on the driving shaft, input, and a runner on the driven shaft, output. The impeller acts as a pump and the runner acts as a turbine. In the impeller near its axis, the tangential component of absolute velocity is low, where on its near periphery the tangential component of absolute velocity is high. Therefore, when the impeller accelerates, the fluid velocity increases. An increase in velocity also increases kinetic energy. The fluid emerges at high velocity from the impeller, strikes the runner blades, transfers its energy, and leaves the runner at low velocity. Fluidex fluid coupling rigid sleeve coupling.